Okay, we're moving along to B. It wants you to find the second derivative to determine whether part A is an underestimate over an overestimate. So when you make this tangent line and you use that to find out the temperature at 3, is that an under and over an estimate? So of course the first thing you have to do is find the second derivative. So d2h dt squared is equal to negative 1/4, and we're looking at this right here and taking the second derivative. And remember, we're taking it in terms of t, and there's no t, so it would be h prime. It would be one, we only have one variable. It'd be negative 1/4 h, and then plus a constant, so that would go away. And then it's not, when we take the derivative of h in terms of dh dt, it'd be h prime. So we have 1/4 h prime. Now h prime is dh dt, so we have negative 1/4 dh dt, which is equal to negative 1/4, and dh dt is negative 1/4 h minus 27. So when we put that all together, we get positive 1/16 h minus 27. So that's the second derivative. Okay, now in order to know whether it's an underestimate, overestimate, we need to find the concavity, which is why they asked you for the second derivative. And basically you have to figure out whether it's greater than 0. And so they go back here to this internal temperature of the potato. I'm looking right here, is set 27 degrees for all times greater than or equal to 0. So if it's positive, so since t is greater than 0, then h is greater than 27 degrees for t is greater than 0. That was given. And then we know that because of that, d2h dt squared, which is equal to 1/16, h minus 27, has to be greater than 0, because if h is greater than 27, see right here, we have h is greater than 27, and then in this second derivative of h minus 27. So that means t is greater than 0, so this has to be greater than 0. Okay, I hope you understand that. Try to say it one more time. We were given this, okay, and they gave it to us for a purpose. They said, hey, every time you have a temperature greater than 0, and we're